Hello, hello, hello. Hi chat. How are you guys doing? Welcome back to the channel. Um this is Mr. Allen's teaching channel, or the Matcha teaching channel for short, and it's stoked. It's a day to be pretty excited by, as I'll be going through a paper for mainly my year 9s, but it's also a good revision for all my students who have done so many different other subjects. And definitely it's a good revision for you to look back at the basics of chemistry and rebuild your foundation. And so first thing, I would just like to give out a shout out to my members of the chat here. Let me just move up my other screen to the top, moving up. And so just a quick let's lower down the music to a lower volume so that we have a bit of time. And yeah, okay, so let's see who is in our chat today, right? So we have the la the Lagis C. We also have Potato. We have Michael. Welcome, welcome, welcome. That Welcome back to this channel. And I hope you're having a good day. And I hope that you always have a good cup of tea to keep accompany you. As I am accompanied with not matcha tea today. My matcha supply has run out, so I'll have to restock it somewhere soon. If not, I'm gonna get cravings. And so I'm only accompanied by my Chinese tea here. And yeah, so today what we'll be doing is we will be looking at a paper at the year 9 media paper. We are definitely hoping that we can do we're going to try and complete this in 1 hour, because surprise surprise, it is a 1 hour paper. And I'm going to try to show that it is very much possible to finish it in 1 hour. And I'm going to try to show it more of as if I wasn't complete. I was trying to show it as if I was a little bit weaker, as if it was myself, maybe 4 years, many years back, when I was in um my own form 4 or my year 10 days. And I'm trying to explain how to do this. So without further ado, I'm just gonna quickly to switch out from the current into the question. We have only 1 hour, and after that and hopefully I finish. If not, I'm probably going to get criticized by all my students, because it's because I only gave them 1 hour. So yeah, let's get to it. So we're gonna move this to the top, and I'm gonna bring up this Zoom board. And so yeah, let's just get into it. I'm not going to show the front page, and I'm just going to go straight into the questions. Now, if you're my year 9s and you were doing this paper, you know that this question looked a little bit different, and I did make this question a little bit simpler, in the sense that I understood that I didn't cover diffusion as deeply as I could. So I put this as which two gases have the same molecular mass. And how we calculate the molecular mass is by looking at the names. This is carbon monoxide, so this is CO. This is carbon dioxide, CO2. This is carbon monoxide, CO. This is nitrogen, N2. This is chlorine, Cl2. This is fluorine, F2. This nitrogen, N2, and this oxygen, O2. Now if I quickly scroll all the way back to my last page, I am going to just very quickly look at my numbers. So chlorine is 35.5, fluorine is 19, oxygen is 16, carbon dioxide is 12, and let's see, nitrogen is 14. So very quickly, I'm going to bring myself back up here, and I'm going to quickly calculate this. So CO is 12 plus 16 is 28. 12 plus 16 plus 16 is 44. 12 plus 16 is 28. So I'm just actually going to write it here so that I don't forget. Nitrogen is 14. Fluorine is 19. Chlorine is 35.5, which is what you should be doing in case. Now, it's always taking a lot of time to actually flip back from one page to another to the periodic table. So I do recommend, one of the good habits is to actually write down the excuse me, the numbers on the side so that it's easier to calculate. So it's 12 plus 16, 28. 12 plus 16 times 2, 32 plus 12, 4. Carbon monoxide is 28. Nitrogen is 49, so it's 28. So immediately, you get the first answer, which is B. Now, X, Y are two different elements. They have the same number of nucleons. Nucleons, you must remember, is the mass number or the RAM. They have the same, so option A, right? Option A, they have the same physical properties. That's impossible. They are two different elements. Their atoms have the same number of electrons. Also impossible. They are not the same element. They are in different groups of the periodic table. This is definitely correct. And they have different relative masses. No, because they have the same mass number. So by process of elimination, the only answer is C. Now this question, question 3, is a memory question. You should remember that diamond is shaped as a tetrahedron, while silicon dioxide, for oxide, I'm used to saying silicon dioxide, has the oxygen atoms in between. This gives you only one answer, which is C. Question 4. Diamond and silicon oxide. These are giant covalent structures. If they're giant covalent structures, they are definitely not malleable. They're definitely not brittle. They do not have low melting point. So A and C is all giving you a 50-50 with B and D. But we know that diamond is hard. Those diamond rings that you might have gone through or you see in your dramas, they are hard. They're not soft. So that gives you the answer for question 4, which is B. Question 5. The number of protons and neutrons and electronic structures of 4 particles, W, X, Y, and Z, are shown. Same chemical properties. This should tell you that we may be looking at an example of isotopes, where the only difference, they should have the same number of protons, but different number of neutrons. And some of you might ask, why isn't it W and X? 8, 10, 8, 10, but the electron structure 2, 8, 2, 6. This kind of tells you that there's 10 electrons against 8 protons. And this tells you that W is an ion. And if it's an ion, we shouldn't include it in the isotope process, giving us the answer X and Y. The next question, metal and ionic compounds have similarities and differences. Which is a similarity and which is a difference? The answer is actually A. Both contain positive ions. Metals have cations within a sea of delocalized electrons. Ions are arranged in an alternating lattice. They are the only ones to contain anions. Question 7. Which diagram represents the outer shell electron arrangement in a nitrogen molecule? Now, if you know the simplified dot and cross diagram, you should also see that they have placed it in that form. But also please remember that nitrogen is 2, 5, meaning it needs plus 3 more electrons to form valence noble gas configuration. Now it's plus 3 electrons, it needs to share 3 electrons. So they'll share 3 electrons with each other. If they want to share 3 electrons with each other, we're going with question D. Answer D, because that is 1 pair, 2 pair, and 3 pair. Question 8. Which dot and cross product diagram shows the arrangement of hydrogen chloride, HCl? Now, if you see, oops, okay, whoops, let's just quickly, apologies, wrong file, nothing to see there. Now, if you see HCl, right, hydrogen is 1, meaning that has only 1 valence electron shell, and so its maximum number of electrons to be placed in that shell is 2. Therefore, this is not hydrogen, this is not hydrogen. Chlorine is 17, group 17. If we see over just now when you're scrolling, chlorine is going to be here. Group 17 with 17 electrons is going to be 287. It's 287 means it has 7 electrons in its outer shell. This gives us only one option, which is the answer A, where hydrogen gets 2 electrons for a full shell, chlorine gets 8. Now this question also I did make it slightly easier by pretty much because you guys did not learn the process of precipitation yet. So I did nerf this question a little bit to suit the year 9s. So I told you that barium chloride was a solution and that barium sulfate was a solid. Now this means that barium sulfate is immediately solid and barium chloride is immediately an aqueous. Now year 10s, if you are grumbling at the back, which I'm guessing if Kaijun is in the he may be, do remember that this is year 9s. They have not experienced what you guys have, and so keep your horses about you. We'll get to you guys soon. This immediately should have triggered a 50-50. But let's just say that most of you probably didn't catch on to that. Now the answer is A, because sulfuric acid, when we talk about an acid, we are almost always talking about an aqueous compound. Question 10. Now question 10, I did mention it very, very briefly when I was talking about RAM. And I told you that RAM is always related to carbon 12. So the answer for question 10 is definitely A. Carbon 12 is our reference molecule. Now question 11. Question 11 was meant to be a very easy question. So they say 0, if you see this is a ratio of 1, 1, 1, 1. So 0.5 moles raised to 0.5 to form 0.5 and 0.5. Oh, sorry, eraser. What am I doing? This 1 to 1 to 1 to 3. So 0.5, 0.5, 0.5 to 1.5. And then to get volume, 0.5 times 12 gives you times 12 pull up times 24 gives you 12 decimeter cube. 1.5 times 24 equals to 36 decimeter cube. Giving you question D. A compound of element X has a formula X2O and a relative formula mass of 144. This means 2X plus oxygen, which is 16, equals to 144. Now this is mathematics. 144 minus 16 equals to 128. X equals to 64, meaning that the mass number of X is 64. Now which of our elements has a mass number of 64? Aha, we found it. It's copper. Oh, give me a minute. Alright, we're back. Control. So we're gonna give ourselves the answer over here, which is going to be copper. Now this is a calculation question, which I have taught you guys. So 0.1, now 100 centimeter cube, you should always divide by 1000 to make 0.1 decimeter cube. Times 0.1 moles gives us 0.01 moles. So this is 0.01 moles of lead nitrate. And this is a 1 to 1 ratio. That means that 0.01 gets 0.101 lead chloride. Now let's find lead 2 chlorides mass number, and that's why lead 2 chlorides mass numbers, right? So lead is going to be here, 207. Chlorine is 35.5. So we punch in our calculators. 207 plus 2 times 35.5. 2 times 35.5 is 71. 71 plus 207 is 278. And times 0.01, we get 2.78 grams. Now, electronic structure of element Z is 281. 1 means it's an alkali metal. So it's definitely a metal. It does not have 2 outer shell. You can see there are 3. So 2 is immediately out, giving you by process of elimination. The only answer is C. 3 electron shells. First, second, and third. Next, why pH 13 is something which we call basic or alkaline. pH 1 is acidic. Now, if you remember, I told you that non-metals are acidic. So X must be acidic and a non-metal, giving you the only answer of B. Now, elements in group 4 are listed below, which does not occur in group 7 as it descends. Firstly, now because they are staying out of group 4, the minute they say they have more electrons in their outer shell, this immediately becomes something of a red flag to you. Because you guys know that the only thing constant in a same elements of the same group is the electrons in their outer shells. Now, question 17. M plus, M2 plus. These are two different oxidation states. When it's two different oxidation states, it must always be transition elements. Now, hint, right? This is for kind of foreshadowing answers to your next questions in the subjectives, and I'm kind of surprised that quite a few of you didn't take use of this. Now, which elements have both a high melting point and variable oxidation states? Also transition elements. Now, this is an issue of trends. If we're talking about least dense, there is always the elements on the highest point of the periodic table. So it's lithium, sodium, potassium, chlorine, bromine, iodine, meaning that these two are going to be the least dense. And finally, question 20, the number of protons and the number of neutrons in the atoms of elements X, Y, and Z are shown. X and Y are isotopes of the same element. This is wrong. They do not have the same number of protons. Form an ion with 2 plus charge. Impossible. This is 2, 6. It cannot give away 2 electrons. X and Z form an ionic compound. Now, if we look carefully, X is actually C, Z is actually O. They form a covalent compound because both are nonmetals. By process of elimination, you should get D. And that will be and I'm going to stop for a while here and go back to my chat room. I'm going to move this up. And I'm going to look at the questions in the group. And so let's quickly just give a few shoutouts over here. Welcome Yeet, Tan Jingwei, I'm not sure who Yeet, and Shin is here, Lemon Tea is here, uh Kaslana? I am not sure who that is, right? And we have Ren, Bomba, I am not sure. Yeet, I'm gonna assume it's gonna be uh Jaden probably. So so far I hope you guys aren't feeling too terrible. I see Potato was following answering, and also Tanjingwei was also answering. I hope you guys got it correct. And so far, we have about so class is Jason. Okay, interesting. Well, welcome, guys. I hope you guys are enjoying the stream. Probably not enjoying because you're probably realizing what you guys have got done wrong. And so overall, I hope that you guys will take a few things into account. I hope that most of you did make the correct guesses if you were guessing, and I hope you guys are doing well. So now I'm just going to take a quick sip of my tea and we'll get back into paper 2. Alright, now we get into the tough part, right? And I say tough part because I think as I was looking through your papers, I have not marked it yet. I'm just looking through and I don't want to give myself too much heartache. So I'm not marking it yet, and so I was kind of surprised. Something to take note, I'll say, in the next time is to actually always go and do the section B, which is the structured question first, instead of the objective questions, because I think most people finish the objective questions and did not do the subjective questions enough. So with that in mind, I actually like to focus on these questions, right? And now let's go at the first question. This is a basic thing for all of you. You should always remember this. Electrons is -1 and neutrons have no charge. Insert Mr. Allen's joke. A proton, electron, neutron walk in the bar. A neutron asks the bartender how much for this. The bartender looks at neutron and says, for you, no charge. Right? And in terms of relative mass, right, you will notice that we use the mass number is the combination of protons and neutrons. That is because only the protons and neutrons mass count towards the mass of an element. So for this, every neutron has a relative mass of 1, every proton has a relative mass of 1. Electrons have a mass of 1 over 2000, which is about 0. So this is tricky because IGCSE says that only you score these 2 marks, do I give you 1 mark? You score these 2 marks, do I give you 1 mark? So it is possible that if you answered neutron correct, but did not answer electron proton correctly, you might not get marks. Next question, magnesium. Now, first thing very easily we can get is the number of protons. Proton number is 12 and 12. Number of electrons is also 12 and 12 because these are not ions. The number of neutrons is 24 minus 12, 12, 25 minus 12, 13. Again, only if you got a row right do I give you 1 mark and 1 mark here. And why? This is IGCSE rules. So get used to this. Now, why do magnesiums have a charge of 2 plus? The ideal answer is to say donation, or should I say magnesium donates 2 electrons. And the keyword is donates 2 electrons. Now, you want to be really great, write to form noble gas configuration. The next question is on electronic structure. So they're asking electronic structure of 2,8. Magnesium from 282 goes down to 28. Now, they want the particles that have same electronic structure as magnesium. Now, if you had listened to my advice at the start of the year and memorized your periodic table, you'll know that right beside magnesium is something called sodium, which is 281, which could also donate 1 electron to be 28. So the ideal answer would be sodium, Na+, or aluminum, 3+. And an anion with 28 is even easier. Why? Because we have oxygen at 26, we have nitrogen at 25, we also have fluorine at 27. So any 3 answers would be correct. O2 minus, nitrogen 3 minus, or fluorine minus. Carbon 4 minus is a bit of a stretch, usually not. An atom that is 28, there is only one atom that has 28 with a total proton number of 10, and that would be neon. Now this question isn't as easy to see, and would probably I do not blame you if you skip this question, which I think most of you did. But the next question is something important, and this I have actually drawn it out for you. This is metallic bonding. Bonding in a metallic element. When we draw bonding in a metallic element, we are often always going to be talking about metallic bonding. So you'll need to draw sodium plus, sodium plus, sodium plus, sodium plus, sodium plus in all of them. And you'll need to draw a sea of delocalized electrons around them and also among them. So the first point is layers of metal cations giving you first mark, surrounded by a sea of delocalized electrons. Second mark, and strong electrostatic forces for the third mark. Next, conduct electricity. Now, I think I mentioned this in our term paper as well, that when you talk about conduct electricity, there's only two answers. And the answer is definitely not because it is a metal. The answer is always in terms of freely moving something. And in nearly all cases, except ionic compounds, the answer will always be freely moving electrons. For those who had studied under me in year 8, you know that a electric current is moved by the flow of electrons. And because metals have freely moving electrons, that is why there is a electric current. If you do not, this is another reminder for you. You have to remember this. Now, sodium chloride, NaCl. Now, this example, I hope that when you were reading your book, you definitely saw this example because it is the first example of ionic bonding I gave to you guys. And that slide kind of tells me the sadness I saw when I saw some of your answers. The answer is ionic bonding. One is a metal, one is a non-metal. Metal plus non-metal. And in this case, since the previous one was freely moving electrons, only for ionic bonding, ionic compounds is it freely moving ions. And that's all you need to write. Sodium chloride has freely moving ions. You want to explain on whether in the lattice it cannot move, but outside of the lattice it can move, that's also fine. Isotopes, now this is important. Same number of protons. This is again something to memorize, but different number of neutrons. You can also say different number of nucleons. I accept both. Marks are given. You tell me same number of protons, but different number of nucleons. Now, next question. Another easy one. State the nucleon number. Nucleon number is your mass number. Let's just go to manganese. We are finding for manganese, right? Manganese. Like manganese. So let's find manganese. Aha, I found it. Manganese is here. The mass number is 55. So all you got to do is just right here 55. Press F in the respects for whoever did not do this, right? Now next, show the number of protons, neutrons, and electrons. Proton is a smaller number, 24. Neutrons is 52 minus 24 equals to 28. And since it's a 3 plus, means it's lost 3 electrons. So 24 minus 3 equals to 21. Now question B. Conduct electricity. Again, transition elements are also transition metals, and group 1 are metals. Metals. So they're always conducting electricity by freely moving electrons. Not because they're metals. That defeats the purpose. Next, state a property that describes a metal which can be hammered into shape. Now, I hope you guys remember many years ago you learned about metals and their properties. And one of their properties is ductile, which means to be pulled into sheets, into strings and wires. The other one is malleable. Huh, I wonder where I saw that word before. Right? I wonder where I saw that word before. Right? Okay, now I'm just teasing you. That's right. But again, I made it a little bit easier. As I said, this paper wasn't that hard because I did a few boogie woogies and it's not a perfect paper by chance. And so let's look at this. So there were questions that kind of helped to answer each other. Next, transition elements. Transition elements differ in other physical properties. They are harder and stronger. Now, I wonder what one of their physical properties can be. Right? high melting point and boiling point. So if you tell me transition metals have higher melting points or boiling points, I give you 1 mark. Your second one should be transition metals form colored compounds. Remember how we all went to the lab and I showed you for some of you guys remember I was talking about copper being blue, iron being green, and all of those stuff. Well, those are transition metals. Now, fluorine and chlorine are halogens. Now, this is a little bit of a tricky one and it's not as clearly mentioned, but the appearance of fluorine is actually pale yellow. It's a pale yellow gas. If you wrote yellow, I might accept it. It'll depend. You have to talk to me on that day. And again, we're back to drawing the electronic arrangement. Nitrogen is 25, chlorine is 287. This one is plus 3, this one is 1. So if chlorine is X, in this case, chlorines will share 1 electron each. 3 chlorines each share 1 electron with nitrogen. And nitrogen will share 1 electron with each chlorine. And now we count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And if they're all correct, and you have all 3, I give you 3 marks. 1 mark if you show me the bonding in each of them. 1 mark if you show me that all chlorines have some more electrons. 1 more mark if you show me nitrogen has 2 electrons as a lone pair. Next, lithium. Again, I flipped to the wrong one. Lithium is 3. This means that lithium is 2, 1. So lithium is 2, 1. Chlorine, as I mentioned, is 287. So 1 more ring. I can hear the internal screens of people who did not realize that there was an extra ring. And this is something I reminded you guys. So chlorine is 287. So let's quickly draw its other set of electrons. Lithium is going to be X's because these are dots. So lithium donates 1 electron to chlorine. So the electron now is here. Lithium is plus, chlorine is minus. Marks if you show me lithium is 2 electrons. 1 more mark if you show it is shared. 1 mark if you get both signs correct. Alright, I will now just 1 more question and we are going, and probably I could have taken a little bit of break, but we might as well go the long way. Explain in terms of attractive forces why lithium chloride, ionic, is solid while NCl is a liquid. Now, I've told you guys that lithium chloride is an ionic compound, so it has strong, I like the word electrostatic. You can also use the word interionic. Interionic, between ions. That are strong, harder to overcome, to break, than the weak intermolecular forces, or you can use the word van der Waals forces, of NCl. Marks are given if you show me strong interionic forces, intermolecular forces, harder to break. This gives you 3 marks. Now, keyword, chemical, physical. this is Mr. Allen's brain not working, right? He pretty much put the same question here, except that this no longer has any limits on it. And this makes this question very, very dangerous because now what all that I can do is I can say they are harder and stronger. Transition metals are harder and stronger. And group 1 metals are white. Transition elements are colored. In terms of chemical properties, they have variable oxidation states. Oh, is that the police? Give me just a minute, guys. Give me just a minute, chat. Alright, so that good news, that was not the police, right? But unfortunately, I cannot really respond to that call right now. So variable oxidation states, and they can act as catalysts. So these are two things that you need to remember from your transition metals, and I hope that if you don't remember them now, you'll definitely remember from now on. And for the last question, this is a question of displacement reaction. Insert the jealous girlfriend. You must remember that between fluorine, chlorine, bromine, iodine, this is more reactive, this is less reactive. And so the one that has more reactive has more risk, so it can displace those with less risk. So you can see bromine displaces potassium iodide because it has more risk. So chlorine is going to be able to displace potassium bromide potassium iodide because it's higher than bromide iodide. And for the other three, it's going to be just X, X, and X. And that is actually the entire paper in one in 40 minutes. Well, 40 minutes. So let's just come and see back. So I got a lot correct, and then Michael's. Then yeah, Mark now and tell us, Mark's no way, man. That is Mark's a secret until next week. And yeah, so year 10, well, year 10's mid-year paper is gonna be later on. I will actually be looking at year 10 papers a little bit later on. I'll try to do a video on it, but I'm actually busy, and I wanted, since I did a paper with for the year 11s, but then year 10s were also here, so I'll do something for the year 9s this year. But don't worry, I'll definitely be getting to the other papers. So let's just read a few comments, and while I'm in the chat room, I'll just like to hear also from you guys, like what do you guys what are some of your questions that you have with regards to like with regards to some of the questions over there, and I'll try and answer them. I've got about maybe about another 10 more minutes in me. So yeah, and so yeah, we'll take some questions from the chat, and I'm just gonna chill and play a bit of music. Just a bit of music though, not much. I see laughter's hearts 100%, 100%. So again, I think it'll take some time to actually digest through this entire paper. It's not an easy one by any means of the imagination, but I'll say that we'll definitely be an interesting how you guys are able to actually kind of look through and reflect on the paper itself. So yeah, I'll probably take about 10 minutes and we'll let any people with any questions um come along and I'll try and answer them. I wish I could put up now I can now you guys are thinking why maybe let me think about how I can work such that I can put both of the but no I can't. So right now I'm kind of trying to project my I was thinking about how I can actually put my slides on the screen as well, but I can't really do that without open my display capture and that kind of doesn't work. So why are the questions so confusing? Like the chemicals and bonding and explaining. I think when you're talking about in terms of confusing, I think it's more about understanding what they're always asking. Like especially like when they talk about um key it's about recognizing keywords honestly. So like whenever you think about conduct electricity, it's always going to be about freely moving ions or freely moving electrons. That's something that will always come out and will always be consistent. Such that if it's an ionic compound, you're always talking about freely moving ions. While if it's a metal or graphite, you're always talking about freely moving electrons. And then if we're talking about like some of the terms like isotopes is something you need to memorize and like things that are very clear and you also need to get used to the synonyms. Like the terms on nucleon number is the same as mass number, same as atomic mass. Proton number same as atomic number. And you guys just will need time to get used to it. I've also, if you check my notes, I've also shown that this and this is the same meaning. So it's more of memorizing this. And you need to be very clear on those keywords because those keywords give you kind of the answer straight away. Then as for the properties, physical properties are appearance, color, um, color, and strength. Like how the texture of it, is it soft, is it hard? And if we're talking about chemical properties, it's about their reactions, so and their charges. As for to reply to Delaji, I'm definitely going for Chem. So I'm definitely going for Chem, and I'm definitely looking forward to having fun with all you there. Michael says I couldn't understand the question. I think that is something that is really common, and I think it's important to embrace failure as one of the ways to learn. Um, it's also for the year nines. It's the first time you guys are facing a full IGCSE paper because I'm giving you full papers. These are real actual questions from real actual papers. I definitely will say that it's definitely more confusing, and I've also tried to give you a few more questions through the quizzes that we've done, but I think it's still too so much wider, and that part of it is also just practicing, being more consistent with your practice and looking at more questions. So not understanding questions the first time round is fine. You can ask the year 10s here. They probably suffered through their chemistry as well. Um, and it's just a matter of okay, I made these mistakes. We'll learn from it. And yeah, also it's a bit more of like how you actually plan out your uh ex- you plan out your time. In this case, I show you that I went for uh the front part, section A first, but you guys could kind of see that section A objectives took pretty much nearly as long as a section B, meaning that it would be better to do section B first and get some of the easy questions out of the way. And that will actually help you a little bit. So next time when you're doing like the theory and objective mixed questions, I definitely recommend going for the structured questions first because it just gives you a bit more freedom and there's higher marks over there. So yeah, not sure whether the rest are still here, but and so yeah, I'll probably leave. We probably still have one time for another question if you guys have, and if you guys still have the questions, definitely just drop it down and I'll try and answer it before we kind of wrap up the session today. Also, apologies if you hear my cough, it is kind of loud. I've been having this very persistent cough all last few days. You saw me with a mask today. So I'm just gonna try and self-treat it and try and come back stronger next week. Probably tomorrow as well. So yeah. And I mean, the total length of the time was about 40 minutes, and this was on full understanding. I think if you're an average student, probably 55 minutes, you definitely would be able to finish the paper with probably a 60-70% accuracy. If you are a better student, you probably could hit 70-80% accuracy. But this was definitely not by any chances an easy paper. This is more my own standard levels. Uh, it's one that challenges you in terms of your understanding. And as you guys can see, I also tried to work out some ways that could make it easier for you to understand some of the questions. So yeah, menjaga badan, yalah, of course lah. I'll definitely take care of myself, and yeah, we'll definitely see. So I don't see any questions. So if that's the case, I'm going to end my stream right now, and I'll catch you guys in the next one. For the next one, we might take a look at chemistry papers. I just realized, wait a minute. I just realized the year 10s nearly just bamboozled me into to trying to discuss year 10 papers when your year 10 papers is tomorrow. Dear gods, my brain was not working. And a good thing I didn't fall for that, right? Uh, well, trolling a sick teacher, and if I actually show it, that would be that would be kind of dangerous. So okay, yeah, all right. So yeah, that's all for today. Big shout out to those who stayed to the end. I think we have Jason, Michael, we have Delaji, we also have, and also a shout out to everyone who was in the chat. We had Yeet, which I believe is we had Yeet, we have Ren, we have Lemon Tea, and I yeah, don't, we have we have Shunan, we have Jingwei, we had had you guys. I think this is we also have Kason. Kason is yeah, our is like haha. I nearly trolled teacher, and that would have ended my career. And so yeah, thank you guys for watching, and I will catch you guys next time. Until then, peace out and drink more tea, right?